It is possible to install a residential generator with a lower power output than the intended electrical load. However, this is generally not recommended. Firstly, an undersized generator may not provide enough power for the electrical demands, potentially causing power outages, reduced appliance performance, or damage to sensitive electronics. Secondly, undersizing can force the generator to work harder, leading to overloading. Overloading can cause overheating, shorten the lifespan, and even lead to failure. Thirdly, an undersized generator might not power essential appliances during an outage, causing inconvenience or safety risks such as not being able to power medical equipment, refrigeration, or heating and cooling systems. Fourthly, undersized generators tend to run constantly or frequently overload, leading to increased fuel consumption, higher operating costs, and reduced fuel efficiency. Instead of undersizing, it is best to properly size the generator to meet the electrical load requirements. This involves calculating the total wattage of all appliances and devices needed during an outage while accounting for surge loads, especially for motors and compressors. Oversizing the generator by 20 to 30% is generally recommended to provide a buffer and ensure reliable operation. Consulting with a qualified electrician is advisable to determine the appropriate generator size and installation requirements for specific needs. Accurately assessing your power needs is crucial before selecting a generator. This involves understanding the difference between running watts and starting watts. Running watts, also known as continuous watts, represent the power an appliance or device constantly consumes while operating. Starting watts, also known as surge watts, represent the extra power required for some appliances, especially those with motors, to start up. For example, a refrigerator might have running watts of 150 watts, but require 600 watts for starting. To determine the total wattage needed, list all the appliances and devices you want to power during an outage. For each item, note the running watts and starting watts. If the starting watts are not listed, a general rule of thumb is to multiply the running watts by 3 for appliances with motors. Add up all the running watts to get the total continuous power requirement. Then, identify the appliance with the highest starting watts. Add this starting wattage to the total running watts to determine the peak power requirement. The generator should have a continuous wattage rating that is equal to or greater than the total running watts, and a surge wattage rating that is equal to or greater than the peak power requirement. Consider future power needs. As your household grows or your lifestyle changes, your power needs might increase. It's wise to choose a generator that can accommodate potential future power requirements. Choosing a generator with a larger capacity than currently needed provides flexibility and prevents the need to replace the generator prematurely. The type of fuel the generator uses is another important consideration. Common fuel options include gasoline, propane, and natural gas. Gasoline generators are generally less expensive to purchase, but gasoline can be more expensive and less convenient to store than propane or natural gas. Propane generators offer longer run times than gasoline generators, and propane can be stored for extended periods without degrading. Natural gas generators are connected directly to your home's natural gas line, eliminating the need for fuel storage. However, natural gas generators require a professional installation. Noise level is another factor to consider, especially if you live in a densely populated area. Generators can produce significant noise which can be disruptive to you and your neighbors. Look for generators with lower decibel ratings. Some generators come with noise reduction features such as mufflers or enclosures. Automatic transfer switches can automatically switch from utility power to generator power during an outage. This eliminates the need to manually start the generator and transfer the load, providing seamless power during an outage. Automatic transfer switches also protect the generator from backfeeding power into the utility grid, which can be dangerous. When installing a generator, it is important to follow all local codes and regulations. This may include obtaining permits and complying with specific installation requirements. A proper installation can void the generator's warranty and create safety hazards. Regular maintenance is essential to keep the generator running smoothly and extend its lifespan. This includes changing the oil, cleaning the air filter, and inspecting the spark plugs. Follow the manufacturer's recommendations for maintenance intervals and procedures. Consider a portable generator for flexibility and affordability. Portable generators are smaller and less expensive than standby generators. They can be easily moved to different locations as needed. However, portable generators require manual starting and fueling. Standby generators offer automatic operation and seamless power during outages. Standby generators are permanently installed and connected to your home's electrical system. They automatically start when the power goes out and shut off when the power is restored. However, standby generators are more expensive than portable generators and require professional installation. Before purchasing a generator, research different brands and models. Read online reviews and compare features and prices. Consider the generator's warranty and the availability of customer support. A well-researched decision will ensure that you choose a generator that meets your specific needs and provides reliable power during outages. Consider the altitude at which the generator will be used. Generators produce less power at higher altitudes due to the lower air density. If you live at a high altitude, you may need to choose a generator with a higher wattage rating to compensate for the power loss. Check the generator's specifications for altitude rating information. Consider the environmental conditions in which the generator will be used. Generators should be protected from rain, snow, and extreme temperatures. Choose a generator that is designed for outdoor use and has a weatherproof enclosure. If you live in an area with frequent power outages, consider a generator with an automatic start feature. This will ensure that the generator starts quickly and automatically when the power goes out. Choose a generator with a low oil shutdown feature. This will protect the engine from damage if the oil level gets too low. Some generators have a carbon monoxide detector that will shut down the generator if carbon monoxide levels become too high. This is an important safety feature, especially if you plan to use the generator indoors or in an enclosed space. When using a generator, it is important to follow all safety precautions. Never operate a generator indoors or in an enclosed space, as this can lead to carbon monoxide poisoning. Place the generator in a well-ventilated area away from windows and doors. Use a carbon monoxide detector to monitor carbon monoxide levels. Never refuel the generator while it is running or hot. Let the generator cool down completely before refueling. Use a fuel stabilizer to prevent fuel from degrading during storage. Store fuel in a safe and secure location away from heat and flames. Inspect the generator regularly for any signs of damage. Have the generator serviced by a qualified technician if necessary. Be aware of the noise level of the generator and take steps to minimize noise pollution. Use a generator enclosure or muffler to reduce noise levels. Avoid operating the generator during nighttime hours if possible. Be considerate of your neighbors and keep the noise level to a minimum. When connecting appliances to the generator, use heavy-duty extension cords that are rated for outdoor use. Do not overload the generator by connecting too many appliances at once. Check the generator's wattage rating and do not exceed it. Turn off appliances before disconnecting them from the generator. This will prevent damage to the appliances and the generator. When storing the generator, drain the fuel tank to prevent fuel from degrading. Clean the generator and cover it with a protective cover. Store the generator in a dry and secure location. Regularly start the generator and let it run for a few minutes to keep the engine lubricated. This will also help to prevent the fuel system from becoming clogged. By following these tips, you can choose the right generator for your needs and use it safely and effectively. Generators can be a valuable asset during power outages, providing essential power for your home and family. The National Electrical Code, specifically Article 702, covers optional standby systems, which includes generators. While the NEC provides guidelines, local codes and regulations may have additional requirements. Consult with a qualified electrician to ensure compliance with all applicable codes. The NEC requires that generators be installed in accordance with the manufacturer's instructions. This includes proper grounding, ventilation, and protection from the elements. Generators must be equipped with overcurrent protection to protect the generator and connected equipment from damage. The overcurrent protection should be sized appropriately for the generator's output capacity. The NEC requires that generators be equipped with a disconnecting means to isolate the generator from the electrical system. This allows for safe maintenance and repair of the generator. The disconnecting means should be readily accessible and clearly labeled. The NEC requires that generators be equipped with a transfer switch to prevent backfeeding power into the utility grid. Backfeeding can be dangerous and can damage the utility's equipment. The transfer switch should be listed and labeled for use with generators. The NEC requires that generators be grounded in accordance with Article 250. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock. The grounding electrode system should be connected to the generator frame and the neutral conductor. The NEC requires that generators be installed in a well-ventilated area to prevent overheating. Generators produce exhaust fumes that contain carbon monoxide, which is a deadly gas. The generator should be placed in an area where exhaust fumes can dissipate safely. The NEC requires that generators be protected from the elements. Generators should be installed in a weatherproof enclosure or under a roof to prevent damage from rain, snow, and sun. The NEC requires that generators be installed in a location that is accessible for maintenance and repair. The generator should be placed in an area where it can be easily inspected and serviced. The NEC requires that generators be labeled with the following information: manufacturer's name, model number, serial number, voltage, amperage, wattage, and frequency. The labeling should be legible and permanently attached to the generator. When calculating the load for a generator, it is important to consider the continuous load and the intermittent load. The continuous load is the load that will be running continuously during a power outage. The intermittent load is the load that will be running only occasionally during a power outage. The generator should be sized to handle both the continuous load and the intermittent load. When calculating the load for a generator, it is important to consider the power factor of the load. The power factor is a measure of how efficiently electrical power is used. Loads with a low power factor require more power than loads with a high power factor. The generator should be sized to handle the load with the lowest power factor. When calculating the load for a generator, it is important to consider the voltage drop in the wiring. Voltage drop is a decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause appliances to malfunction. The generator should be sized to minimize voltage drop. When calculating the load for a generator, it is important to consider the ambient temperature. Generators produce less power at higher ambient temperatures. The generator should be sized to compensate for the power loss at the highest ambient temperature. When calculating the load for a generator, it is important to consider the altitude. Generators produce less power at higher altitudes due to the lower air density. The generator should be sized to compensate for the power loss at the highest altitude. When calculating the load for a generator, it is important to consider the surge capacity of the generator. Surge capacity is the ability of the generator to provide extra power for a short period of time to start motors and other appliances. The generator should have enough surge capacity to start all of the appliances that will be connected to it. When selecting a generator, it is important to consider the type of fuel that the generator uses. Gasoline generators are generally less expensive than propane or natural gas generators. However, gasoline generators require more maintenance and have a shorter lifespan. Propane generators are more expensive than gasoline generators, but they require less maintenance and have a longer lifespan. Natural gas generators are the most expensive type of generator, but they require the least amount of maintenance and have the longest lifespan. When selecting a generator, it is important to consider the noise level of the generator. Generators can be noisy, so it is important to choose a generator that is quiet enough for your needs. Generators with a lower decibel rating are quieter than generators with a higher decibel rating. When selecting a generator, it is important to consider the size and weight of the generator. Generators can be heavy and difficult to move, so it is important to choose a generator that is the right size and weight for your needs. Portable generators are smaller and lighter than standby generators. When selecting a generator, it is important to consider the warranty. Generators typically come with a warranty that covers defects in materials and workmanship. The length of the warranty varies depending on the manufacturer. When selecting a generator, it is important to consider the reputation of the manufacturer. Choose a generator from a reputable manufacturer that has a good track record of producing reliable generators. When selecting a generator, it is important to consult with a qualified electrician. An electrician can help you to determine the right size and type of generator for your needs and can install the generator safely and properly. In Florida, specific regulations may apply to generator installations, particularly concerning permitting fuel storage and connections to the electrical grid. Check with your local building department for specific requirements. For example, fuel storage may have restrictions on the quantity and type of fuel that can be stored on residential properties. Connections to the electrical grid must comply with safety standards to prevent backfeeding, which can endanger utility workers. Local codes may also address noise levels generated by the equipment, particularly in densely populated areas. The Florida Building Code provides additional guidelines for generator installations, including requirements for structural support, ventilation, and fire safety. Adhering to these codes is essential to ensure the safety and longevity of the generator system. Consulting with a licensed electrical contractor familiar with Florida building codes and local ordinances is crucial for a compliant and safe generator installation. They can assist with the proper sizing, installation, and permitting of the generator, ensuring that it meets all applicable regulations.